Good morning, everybody, and welcome to this brand new new features webinar for Ekahau 9.2. Very shortly, I'm just going to hand you over to Nick Turner, who is going to be doing the presentation for us this morning. Now, we always welcome your questions, but as we have so many people, we are going to rely on the chat client this morning. Please do put your questions forward, and Nick will be very happy to answer them. Yeah, we're going to have everybody on mute this morning. Right, Nick, we're going to go straight into it this morning. Are you ready?
I think I am. I'm gonna rock this session with the webcam up and running, if that's all right with everyone. And yeah, I think we're good to go. Thank you very much for the intro. So let me introduce myself very quickly. I'm Nick Turner. I work for Ekahau. I come from working in the field. I worked as a Wi-Fi engineer for like 3 or 4 years, and now I was a customer of Ekahau, and now I work for Ekahau. The purpose of today's session, we're gonna focus in on the latest release 9.2 new features, the new and exciting shiny stuff, right? So let's just double check that we are running the right version of Ekahau. So just come in here. And so I'm running the 9.2.2 release of Ekahau Site Survey Pro. I'm running on the Mac. Should be same experience though if you're running this on Windows. If you do have questions, please put them in the questions box, and we'll address them at the end. And let's get to it. So there are 3 kind of key shiny new features for 9.2. 2 of them are planning based, so simulation, and 1 of them is survey based. So let's look at the planning ones first. And so the first one is called coverage planning. So what we're going to do is, I could bring in a CAD file and have Ekahau draw the walls for me, but I've already got a project that looks like that. So we'll do this one here. So this project here came from a CAD file. I imported the CAD file to the project and used Ekahau to draw the walls for me. And we're all familiar with the signal strength visualization. We would go to the simulated access point tool, choose the AP model from the list, and we can drop our APs onto our floor plan. What should we do today? Let's go with we're going to go with Cisco for this moment, for this one. So we're going to go Cisco, and we're going to go old school. So we're going to go with like a 2700, 2702i. And when we drop one of those APs into our floor plan, we then get a detailed visualization of the signal strength. Hopefully this is not new to anybody on the call. But the new visualization into 9.2 is called coverage planning, and you can see in here that it is a sub visualization of signal strength. This is to make it clear that what we are visualizing here is the signal strength. So what does this visualization look like? It's a less detailed view of the signal strength threshold value that we have set in our coverage requirements. But the key thing here is that when we bring that mouse back onto the screen, we will get a live update of where that cell edge looks, or where that cell edge will be, live with the AP model that we have selected. And if I drop an AP in here, then that one will appear, and then we can start moving on to the next one. Now, the key thing to remember here is that this is a far less detailed rendering and simulation of the signal strength, signal propagation throughout your virtualized environment, but it's a lot faster. It's an instant update. And if you want to change that threshold, you've got 2 options. You could always go back to the signal strength visualization and drag the slider on your legend, or we could go into project coverage requirements, and it's going to be your signal strength threshold in here that is setting the value for your threshold here. Let's I should have double checked this before we started, but there we go. So that is how the coverage planning tool works. And then everything else is the same, okay? So we would then, dropping our APs in, they're all on channels 1 and 36 at the moment, and then we would want to go ahead and use the channel planning tool to optimize the channel selection of those simulated APs. This is not a good example of great design, but really all we're doing here is having a look at what that coverage looks like when I move my mouse around the screen. Okay, so coverage planning, that's a simulation tool aimed at the Wi-Fi planning process. Special feature number 2 for Ekahau 9.2 is the Bluetooth planning. Now, for this, we're actually going to go ahead and open up that same project file again, this one here. Because what we are used to doing is designing for Wi-Fi, yeah? So this time we're going to go and use we're going to stay in coverage planning, and we're going to use the Aruba 305. Aruba 305 AP this time. So if we go down to this one here, okay. And so we're more familiar with the dropping APs onto the map so that we meet our coverage requirements, yeah. And I'm going to do this with the coverage planning tool here. So we're just going to make sure that we have reasonable primary signal strength coverage like this throughout my design. Now, many of you will have seen this floor plan before because it's the one that we love to use at Ekahau for demonstration purposes. So here we go. I'm just going to drop some APs in here. This is kind of where I think I would put my APs for primary signal strength coverage throughout my site. Okay, and that looks fine. But the new thing here that we're going to focus in on is the fact that these APs have got a Bluetooth radio inside them. So this is the Aruba 305 AP, and there are other APs now supported with the Bluetooth radio, and over time we will be introducing more APs with the Bluetooth radio. Just like with signal strength, though, we're relying, we need the antenna patterns from the vendors to ensure that we get them into our tool correctly. So why would we want to measure, map and simulate the Bluetooth coverage for Bluetooth deployments, be that blue dot experience or potentially asset tracking? Now, there are certain things that you can do with BLE beacons that are in the APs, and then you can supplement that Bluetooth coverage with beacons. However, there are things that I think you can do blue dot experience with APs with Bluetooth and beacons, but when it comes to asset tracking, then I think the coverage that you are looking for has to be coming from an AP. But I'm not 100% sure on this. But for Bluetooth planning, what we can do is now we have another new visualization in here for Bluetooth coverage. So that's down here at the bottom. And so what are we actually looking at here with this one will be the Bluetooth radio coverage provided by the radio inside these APs. And the coloring scheme here is that anywhere where there is no BLE coverage, it's going to be white. Between 1 and 2 radios, it's gray. And then 3 and above, it's going to be shown in blue. And so we are, we're looking for kind of feedback really on whether this implementation is bang on. How do you want to use this? So if you have comments and feedback, do let us know. But we are looking at where we got multiple BLE radio coverage. And the threshold for this, that can be set under options, and you'll see in here minimum signal strength. So this visualization is actually currently showing me where do I have coverage from 3 BLE radios at neg 80. We can look at this and we say, right, well, we're not, if we were looking for 3 BLE radio coverage at neg 80, we can see that my APs, my AP locations are not providing me with the sufficient BLE coverage. So what we can do to supplement this is drop in the beacons. Now the simulated AP tool has a drop down arrow, and we can switch over to the Bluetooth beacons. And let's have a look, what beacons have we got at the moment? So we've got the Aruba ones and a generic BLE beacon, that well-known generic brand. So we're going to go with this one here, and then I can drop in the BLE beacons to supplement my Bluetooth coverage without adding more APs to my design, which of course isn't what I want to do, because more APs does not necessarily mean better Wi-Fi. And in fact, we don't want to sabotage our own Wi-Fi deployment by adding extra APs and having them broadcast, or even worse, we buy an expensive access point and we stick it on site and then we switch off both the radios because really all we wanted was the BLE radio from it. So we can use the BLE beacons to supplement that Bluetooth coverage. Not seeing anything on the questions yet, so that means that everybody is totally happy with what I'm demonstrating, right? If you do have any questions, pop them in the chat, please. Okay, so we worked closely with Aruba for this feature, but we're very keen to hear, how are you guys using the Bluetooth planning functionality? Okay, of course, with the Bluetooth beacons, they're a lot cheaper, they're a lot smaller, they're battery powered. What headset is that? This one here. This is a Bose over-the-ear noise cancelling set of headphones. It uses Bluetooth. That was one of the questions. So, and then on top of this, we would use our area tool to define the region of the map that we consider to be in scope for the project, and we go back to the Wi-Fi coverage requirements under project coverage requirements, and then we go ahead and set all of these details as we would expect. All right. Excellent. So that's the 2 new shiny, exciting features for planning. And now let's talk about the feature that I think everybody really joins the webinar for, and that is to talk about the interference detection that we are introducing. Now, we've got to keep this on the down low, and please nobody tell Mikko that I am sharing this with you. But we have a new feature called interference detection, and it is a beta feature. So it's not really ready for everybody to start using yet, and there are still many improvements that we want to make to this. However, with a feature like this, it's important to kind of be able to view it, in the real world, and we want people to have that experience. So we've introduced interference detection as a beta feature, and it's hidden away. So for this, you do need to have Ekahau Site Survey Pro, and you do need to have a sidekick, because we are leveraging the high resolution spectrum data coming in from sidekick in order to do the interference detection. So this won't work if this feature is not available if you don't have a sidekick. Okay, how do we enable that interference detection? Well, first let's have a look at the spectrum around me. So we're going to go over to the 2.4 gig band, and let's switch that one off. So here we can see my 2.4 gigahertz environment. So what you need to do is on your machines, if you've got Ekahau and you've got a sidekick, you want to focus in on the battery status of your sidekick. And on Windows, you're going to press and hold Control. And on Mac, for me, it's the Alt key. So I press and hold Alt, click on the battery status, and what you'll see here is my serial number, my firmware, and an experimental interference detection checkbox. I'm going to enable that. Yeah, so you enable that, and what we should get is in your real-time frequency monitor, a new option. So we're used to the three, show Wi-Fi APs, max density, and real-time sweep options. But what you're going to get is a fourth one called interference. We're going to switch that to say show interference. And now with that enabled, we will now start doing the interference detection on that survey data, on that spectrum data coming in, okay? So first, what are we actually looking at here and what can we see? So let's go to the waterfall view. And because I'm using this Bluetooth, this wonderful Bluetooth headset, Matt, you can see that there's Bluetooth in my environment. So we can see the narrow spikes of energy hopping around the 2.4 gig band, but the colors up here in the spectrum view indicate that that spectrum utilization is low. Yeah, we're not seeing reds or blacks in the color up here, which means that the spectrum utilization for the energy that we're detecting is low. The timeline, well, the waterfall view over here, we can see the spikes, the little dots of energy all over this place. They, in here, the color represents the signal strength. So what we're saying is that there was a narrow spike of energy, and it was brief because it's only a little dot, but you can see that the 2.4 gig band is peppered with the Bluetooth energy that's coming from my headset. So just hopping back to the Bluetooth topic very quickly, Peter has said, what is the best practice for BLE location? And I'm gonna back out of answering the question and just say, like, we have enabled the ability for you to set the number of BLE beacons at a given signal strength threshold, and I would defer to the vendor and more specifically the application that you're trying to achieve and trying to use over that BLE with that BLE coverage. So I'm not going to wade in there and say what I think, but yes, it depends on what you're trying to do. Absolutely. Right, back to the main event here with the interference detection. I have in my possession a 2.4 gigahertz wireless video camera. It's not a Wi-Fi video camera, and this is called a Hammy camera. It pumps out 2.4 gigahertz energy like a champ. Doesn't care about the Wi-Fi. And so when we switch this thing on, so we'll do this, we'll switch this on, instantly we can see that trace of the energy right there in the spectrum view. And once we now think we know what it is, we're going to draw a red box around that and say, pretty sure this is a video camera. Now, this feature, let me just say it one more time, is a beta feature. It's not polished yet. But what we're doing here is we're able to do the pattern recognition on the energy being received by the sidekick. And you can see there that we've actually misidentified that energy at the moment. And that's okay. Hence the feature is in beta, right? But we are able to identify that energy in that spectrum view and also on the timeline. So if I hover the mouse over here, we can actually see what was being detected at those points in time. So now if I were to hypothesize why this is happening, So baby monitors, some baby monitors are frequency hopping, right? So they'll hop around. But I think what's going on here is that we've got the video camera pumping a nice big Disneyland castle over here on the left, and we've also got the Bluetooth happening over on the right-hand side of the 2.4 gig band. And so I think that's kind of what's happening here with the baby monitor detection. Quick note on spectrum views, one more time. Up here in the spectrum view, the colors represent the spectrum utilization. So black is 100% utilization during the past 5 seconds. In the waterfall, both this one and this one, the colors represent the signal strength. So darker colors represent a strong signal over here and over here. And in the spectrum view, the signal strength is represented on the y-axis, the height, and the frequency, channel number, represented along the x-axis. And we're representing the spectrum utilization or duty cycle with the colors. What are the white triangles in the waterfall view? That is saying this is an interferer, we think, and when I hover the mouse over them, we can view what we thought that was at the time of collection. So that's a warning triangle just to say, you know, we identified this block of energy for this duration of time, and we thought it was video camera. The primary purpose of including the interference detection as a beta feature into 9.2 is the ability to get it into people's hands and let them have a play with it. If you experience difficulties with it, don't let us know at the moment. I think it's not ready. It's there for you to play with and see what else is, you know, what else it can detect and what it discovers it as. That sort of thing would be quite interesting. Actually, I take it back. So maybe do contact us with your findings, but just don't contact us with the problems that you're experiencing with it. Like right now, where my video camera is being detected as a baby monitor, which it's not. The Hami camera has 4 channels, so if I change the channel now, we'll see it hop through the 2.4 gig band. And there is an interesting phenomena which I would like to show you, and let's see if I can. So Bluetooth operates with interference avoidance, right? So Bluetooth does its best to play nicely with Wi-Fi and not have a negative impact on other wireless communications in the 2.4 gig band. And so you'll notice that over here on my long-term waterfall view, you can see that the Bluetooth was peppering all of the 2.4 gig band. But then I switched on the Hami camera and it started hammering channel 1, 2, and 3. Since then, the Bluetooth radios avoided that part of the spectrum because the chipset had identified that this part of the spectrum was in use by something, my interference source, and then it avoided that section. That doesn't always work, and I'm not quite sure whether you're picking up any kind of disturbance with the Bluetooth link here, but it's just very interesting to see that here you can see that Bluetooth was going all over the place, and then as of my interfering device, it has now avoided this section of the spectrum as much as possible. Right, so they are the 3 cool new features in Ekahau 9.2. They're the main ones. There is, of course, many others. We've added some more antenna profiles and, you know, little fixes here and there. That's what the release notes are for. I'm not going to go through them, and I have not memorized them. So, do we have any kind of questions, Carlos? Do you have any questions, Carlos?
We've got a few questions from the team here. So if people want to unlock the obviously the feature that we've just seen, does everybody have to be up to date with the current firmware? Was that in the last firmware update for Sidekick?
Yeah. For interference detection to work, you need to be running the latest version of Ekahau 9.2.2, and yeah, your Sidekick should be up to date for sure. And then to find that feature, it's going to be press and hold Control on Windows, or press and hold the Alt key on Mac, and click on your Sidekick battery health and then you'll be able to enable that feature here. Okay.
Fantastic. And another question that comes up quite regularly in the demos is about the interferers library and how many interferers there currently are in there.
Okay, so that's a bit of a tricky question, and you put me on the spot here. I don't know how many interferers we have currently in this build, but with it being a beta feature, the library is going to be relatively small. But I think the nice thing here is that our interference library will exist in software. So over time, this is going to be an interference library that we can add to, and it can grow out. So as time goes by, we're going to be adding new interference sources, and also getting better at identifying what those interference sources are. So yeah, that's going to be a learning thing. It's going to be a learning process for us and the development team. But yeah, it's a feature that's going to continue to get better.
Fantastic. And certainly it'd be very cool if obviously once it's ready, I guess if obviously the user community could offer up their interference patterns, but I guess we'll have to wait and see on that one.
Definitely. That would be amazing, and we will just have to wait and see what kind of happens regarding that. But I really like the idea of the user base of Ekahau being able to share interference data with us or with each other. We'll wait and see what happens, but yeah, the future's bright regarding interference detection and Sidekick.
Fantastic. Now I can see a couple of questions coming through. So Sean has asked, can we share the release notes? Absolutely, they're online, but to save you looking, I'll make sure the account manager sends you the link to that one. Mr. Molyneux is asking, what type of camera are you using there?
So this video camera is it's a Hami camera, the C200 wireless camera. I'm sure they do have a purpose in the real world, but as far as I'm concerned, it's a very compact internal battery interfering device. I don't actually have a receiver for it, which might be something that I look into at some point. But yeah, it just pumps out that video transmission, and it just doesn't care about interfering with other communication protocols in your environment.
Mike, if you need the details of that, Nick has already shared the camera details, and I'd be happy to pass those on.
Absolutely, and good luck getting them. Because currently I'm schnaffling around eBay, and every single Hami camera that pops up, I'm on that. I'm sniping those bids.
Fantastic. Always great for the user community there, Nick. A serious question then from Lewis. Will it be able to detect radar signals on the 5 gigahertz band?
Very, very good question. Valid. I don't know the answer. I don't know the answer. The resolution of the spectrum coming in from Sidekick is 39 kilohertz, and it's sweeping through both 2.4, 5 gigahertz bands 20 times per second. So let's just work this one out for a minute. Like Bluetooth hops at something like 800 times per second. So when we see the Bluetooth energy here, we're not picking up every single transmission from the Bluetooth device, because we're not sweeping. I mean, we're sweeping 20 times per second, but the Bluetooth radio is hopping 800 times per second. With the DFS events, I I would like to see that as a feature. It's something that we're definitely going to investigate further. There have been internal discussions regarding DFS. I don't know what the outcome is, and so I'm gonna do a pass on this question. I don't know the answer. Keep your ear to the ground, and of course, we'll make a big song and dance about it if we do implement such a feature. Absolutely.
Fantastic, excellent. Well, I'm not seeing any further questions, so guys, I think what we'll do is, as we've published this for half an hour, we'll pause it there for today. Please, if you do have a question that comes up that obviously you don't think of during the session, please do let us know. Nick, people want to know where they get the Ekahau hat.
Okay, so there's no surefire way to get a hat. If you come along to an Ekahau event, such as the Wi-Fi Design Day, because Ekahau will be there, and or the ECSE training. There's no guarantee here, but if when that questions section comes up and presenters ask, do you have any questions, and you come up with a cracking good question, then you get a hat. Or maybe even if you have something interesting that you want to blog about, and you would like to do publish an article on the Ekahau blog, let me know. My email address is nick@ekahau.com, and we can definitely have a discussion about doing a guest blog post on the Ekahau blog, and I would then certainly try and post you a hat.
Fantastic. You heard it there first, guys. Right.
No guarantees, though.
Guys, thank you very much for joining us this morning. Obviously, the recording will be available, I presume, probably either later today or on Monday, which we'll make public for everybody that didn't attend, and obviously anybody that'd like to recap what we're seeing. As Nick said, reach out to him. If you do have any questions, please do reach out to us as well. And obviously, we'll look forward to seeing you at the next event, and for those of you that are going to be joining us at Wi-Fi Design Day. But for this very hot Friday morning, thank you very much, and have a great rest of the day.
Wonderful, guys. Thank you very much. Thank you everyone for attending. Have a great rest of your Friday and a good weekend.
Thanks, Nick. Thanks for everything you've done today. Thanks, guys. Bye for now.